Hello there, it's Alana, and I'm back to help you with 6.2, number 35 from the study plan. Let's see here. So I'm going to view an example. It says, according to an airline, flights on a certain route are on time 80% of the time. Suppose 11 flights are randomly selected and the number of on-time flights is recorded. Use technology to find the probabilities, blah, blah. So first thing they want you to do is determine whether this is a binomial experiment. Find and interpret the probabilities that randomly are exactly 9 flights are on time, at least 9 flights are on time, fewer than 9 flights are on time, between 7 and 9 flights are on time. Okay, lots of things going on. But this problem is actually easier than you might realize. First thing you have to do is establish, and of course, you're lucky because you know what section of homework you're in and everything, that this is binomial. A lot of times things are binomial and you're not even going to be told, and you'll just have to figure it out for yourself. Okay, so lots of things. There are 4 criteria that make something a binomial experiment, and sometimes when you're on your tests or on your midterms or whatever, nobody's going to come right out and say, hey, this is binomial. You just have to know it and figure things out from there. Not always, but sometimes. Okay, so what makes it binomial? It has to, and honestly, there's nothing for me to do here technology-wise. They have it written right here, but I'll talk about them. It has to be performed a fixed number of times. It's not like we just kept pulling flights and pulling flights and pulling flights until we got the number we wanted. No, no, no. They looked at 11 flights. That's it. There's your n. N is 11. As a matter of fact, I will put that in here. N is 11. Okay? That's your fixed number of trials. Okay? You have to have them set ahead of time. Can't just be you go until you feel like it. The second thing is that they're independent. Whether the first flight is on time has no relevance on the second flight being on time. Now, normally that's not actually the case, but since they're randomly selecting flights, then it probably is. Because, of course, if one flight is late, then the next flight behind it will be late. Okay, so that's true, but since they're randomly selecting flights, that's not really going to matter here, right? Okay, so we're going to assume independence, right? Because we're just picking 11 random flights. They're not going to have anything to do with each other, therefore they're independent of each other. All right, number 3. For each trial, there have to be 2 mutually exclusive outcomes. Disjoint, meaning if you have one, you don't have the other. So for us, that would be on time or failure, right? So either they're on time, that's success, or they're late, which is failure, I believe. Let me see. Number of flights on time. Yeah, on time is success in this one. It's not always. Honestly, it doesn't really matter. You could call late success and failure being on time, whichever. But this case, because they're always asking about on time, will make success on time. And then the probability of success is the same for each trial. Well, sure, because they said 80% of all flights. So then we can assume that the probability of success is 0.80. Okay. Now let's make a distribution for ourselves. X is the number of flights on time. Now if you're going to pull 11 flights at random, what's the least number you could have on time? 0, right? And then you could have 1 on time, or 2 on time, 3 on time, 4 on time, all the way up to 11 on time because there were 11 flights here. I'm going to make this problem honestly pathetically easy. It's going to be kind of sad. All right, then what's the probabilities for each one of these? Okay, well, probability, so because this is binomial, we can say binom dot dist. I'm doing binom dot dist because I'm on the newer program, but it's just binom dist in the old program. The number of successes is right here, x, comma, trials, but trials is fixed, so I'm going to give that dollar signs because when I drag this formula down, I don't want that to change. It's in cell B1 for me. And then probability of success, again, I'm going to give that dollar signs because as I drag my formula down, I don't want that to change. And then I'm going to choose false. Okay, and I'll talk about what true means in a second. Okay, and then I just drag it down, and there are all the probabilities all figured out. Kind of beautiful, isn't it? Okay, so real quick, let me just show you what true would look like. Let me copy and paste this in just so you can see it. Now if I pick true, okay, so this is cumulative probability. You'll see what I mean by in a second. So the first one seems the same, right? But if you drag it down, look what happens. So what this number is these 2 numbers added up. And what this number is these 3 numbers added up. And the next number is these 4 numbers added up, and so on. And sometimes that's nice to know. I mean, you can find your cumulative probabilities if it makes you happy, right? What it's doing is it's adding up all the probabilities. So if you say the cumulative, let me put it this way. This one right here is the probability of 8. Exactly. So what's the chances 8 flights are on time, period. This one is the probability of up to and including 8. So it's finding, let me give it a color just for a second. It's finding all of these added up. So it literally adds up all these probabilities and adds them up. So these 8 cells, 9 cells, whatever, add up to 0.3825. See what I mean? Sometimes that's useful to know, not always, but it doesn't hurt you to find it if you want. So I'll just leave it in there. Maybe it'll come in handy. Who knows? All right, so now we've answered part A. That was the whole, it's fixed, it's independent, and all that jazz. Now they want us to find the probability exactly 9 flights are on time. Well, that's super, super easy. Exactly 9 flights, we just found it right here. So let me do this part B. The probability of exactly 9 flights on time. That is equal to this value right here. And I'm gonna, I don't know, give it a color, green, just real quick. And you can see it's that guy right there, 0.295. I can't leave it colored because I think I'm gonna need it for later problems, but that's how it's gonna work. All right, C. C is the probability that at least 9 flights are on time. Okay, so the probability of at least 9 flights on time. Well, that's equal to the probability of 9 or more, right? Oops. It's not going to like an equal sign in the front of that. All right, so now how do we find the probability of 9 or more? Well, that's equal to the sum of 9 or more, these 3 boxes down here. Here, let me show you real quick with a highlighter. It's these 3 boxes, 9, 10, and 11. Those 3 probabilities added up. By the way, another way you could find it is 1 minus this probability right here. Here, let me highlight him. Because if you take this probability, what you're doing, ooh, I better give him a different color. Here. What you're doing is finding what all these orange ones add up to, right? So if you find what all these orange ones add up to, it's 0.38. So then you take 1 minus that, and you're going to have what these 3 yellow ones add up to. See? So it works either way. So that's where the cumulative stuff comes in handy sometimes. So sometimes it's nice to have the cumulative stuff figured out. Right? All right, I'm going to unhighlight all of that because we can't keep things highlighted because I got to answer more questions. All right, so that's the yellow one. I'm going to make it yellow. All right, next. What do they want? Oh, fewer than 9. Oh, heck, that's easy. We just did that one. Probability of fewer than 9 flights on time is equal to, all right, now fewer than 9 would be, 9 doesn't count, right? So 8, 7, 6, 5, 4. So this is the probability of 0 up to and including 8, right? Or how about this, 8 or less? Let's put it that way, 8 or less. So we can do this a couple ways. You can find the sum of 8 or less, which is all the way from 0 to 8. Let me do it. And we just found it in orange just a minute ago, so I'm going to leave it orange. That's what all these probabilities right there. But you can see it, it's right here. So if you found the cumulative, you've actually already found it, right? Now, of course, it didn't actually tell you to come up with a table to answer these problems, but isn't it a lot easier to be able to kind of visually see what's going on? I think it's a lot easier. Of course, if you're doing it raw without a table, then you'd have to sit there and like find each individual probability just like we're doing, right? But I think the table really helps a lot. All right, let's see what they want for E. Oh, 7 and 9, inclusive. Inclusive means you get to include them. So the probability between 7 and 9 inclusive, that would be equal to the probability of 7, 8, or 9, right? So you'd add them up. Oops. So this is the sum of from 7 through 9. I'm going to unhighlight all this because we don't need any of this. I'm going to make it this. Let me just show you what I'm adding up. I'm adding up these 3 right here, right? Those 3 summed together make 0.627. Okay? And again, it didn't tell you to do a table, but oh my gosh, it is so much easier to do a table. And you didn't have to do this cumulative thing. I was just throwing that in there because people are always curious about the false versus true thing. It actually is easier to do this cumulative thing to find. I think this yellow one and this orange one in particular was really easy to find from that table right there. But other than that, you don't really need it. Okay, you could have found that just by summing all of these. And of course, since you're working with a computer program, it's super simple to sum and add up from 0 all the way up to 8. All right, we're done, and I hope that helps. Oh, I suppose I should double check that I did all this right. Otherwise, I've just led you astray through this whole video. So let's see what they came up with for the answers. Oh, formula. Who cares about the formula? We're not doing that formula by hand. Just ignore all that stuff. That's all by hand stuff. So they said the first answer for B was 0.2953. That was we said right here. That's the green one. Oh, I didn't even do, let me round to 4 decimal places real quick, just because it'll be easier for comparison's sake. Yes, I do know how to round. There's other ways to round with Excel, but I'm going to be lazy here and just do it quick. Okay, so 0.2953, then let's see. Hopefully they say 0.6174. There it is, 0.6174, just like we said. 0.3826, there we go. That's that one. And 6275 is the last one, just like I found. Fabulous. All right, I hope that helps. Talk to you later.